Hi guys, welcome to my channel AlgoCraft. In this video, I'll be solving one more problem from the Algo Expert site and from linked list playlist, and the problem name is merging linked list. Okay, so some of the linked list I have already covered in my previous video, and today I'll be solving the merging linked list problem. Okay, so the same problem that is available in the LeetCode side, and the problem name is intersection of two linked list. So what the basically problem state that you will be given two singly linked list head A and head B, and you need to write a function to find the node at which two lists are intersect. If two lists have no intersection, you need to return the null. Okay, so let's see this problem with an example. Let's say we have a list 1 with 4, then 1, then 8, and 4, then 5. Okay, and then we have another linked list. Let's say 7, then 2, then 3, then 4, or 8. Let's say 8, then 4, then 5. Okay, so now you can see that both the linked list have intersect at point 8, right? So this is the node where basically two linked list has been intersect each other. So you need to return that node. Okay, so you need to return the start point, start node of the intersection point. Okay, you need to return 8 in this case. Okay, so this is the answer. So how can you solve this problem? Okay, to solve this problem, what is the basic brute force approach we can apply here? So basic brute force approach is you can start iterating each node in a head A and compare each node of head A with head B. Okay, if you able to find any node that are matches, then that case you are able to find out the intersection point. If no node matches each other, then that case there is no intersection point, you need to return the null. Okay, so what is the approach? I will start iterating every node of head A, and for every node I will start comparing whether the same node exists in the head B or not. If I able to see that two node has the same value, then not same value, two node is basically the same, then you need to return that node. So that's mean that is the intersection point. But here the time complexity is order into m into n, because for every node head A you comparing every node with head B, right? So that case in the time complexity is order of m into n, so that is not optimal one, you need to optimize it. So another approach you can apply is hash set. Okay, so what you can do, you can create a hash set of node, and you store all the node of head A in that hash set. Okay, and then you iterating the second linked list and start checking for every node whether it is exist in the hash set or not. If it is exist, then that case this is the node which basically intersecting, which basically the intersection point of these two linked list. So you need to return them. But here is time complexity is order of m plus n, because you are iterating this loop, this linked list one time, and after that you store all of node in a set, and then you again iterating the next second linked list and start checking whether the same node is already exists in the hash set or not. So in that's why the time complexity order of m plus n, but here you are taking the extra order of n page complexity. So that is here the time complexity is optimized, but the by doing that you are taking the extra page. Okay, so you need to optimize the page complexity as well. Okay, now we can optimize the page complexity as well. So for that, what we can do, we take two pointer. Okay, so let's say 4 5. I'm just writing the linked list once again. 7 2 3 8 1 5. Okay, now what I will do, I will take one pointer p1. Okay, and another pointer p2. So p1 pointing to the first node of the head node of the first linked list, and p2 is pointing to the head node of the second linked list. Okay, and I will start moving p1 and p2 one step at a time. Okay, so at the beginning p1 and p2 at the head node. Okay, and I will start checking until p1 equal to p2. So until p1 not equal to p2, I will start checking this. Okay, and so as you can see, the p1 and p2 both are not same, right? So I will move both pointer. P1 now pointing to here, p2 is now pointing to here. Again p1 is pointing here, p2 is pointing here, p1 is pointing here, p2 is pointing here, p2 p1 is pointing here, and p2 is pointing here. These are not the same, right? After that, so at this point p1 is reaches null. Okay, so and p2 is pointing to 4. Okay, now when p1 is reaches null, what I will do, I will reset the p1 to pointing to head of the second linked list. Okay, so now in that case p1 is now pointing here. Okay, and p2 is pointing to 5. Okay, after that p2 is the last node, right? So p2 next is null. So when p2 is reaches null, so in that case what I will do, I will also reset the p2 that will pointing to head of the first linked list. Okay, so now p2 is pointing here and p1 is pointing here. Okay, now I will start checking whether p2 and p1 are same or not. It is not same, so I will move both pointer one at a time. So p2 here and p1 is here. Okay, after that p2 is here and p1 is here. At this point you can see that both p1 and p2 are pointing to same node. Okay, so that's mean this is the intersection point, and you just return the p1, right? So I hope you are able to understand the solution, but why this switching in between pointer works. Okay, let's understand this first, because lots of other YouTubers don't explain that. So I'll explain this. So let's say A, okay, A is the length of the non-intersection part of first linked list. Okay, and B is the non-intersection length of the non-intersection part of second linked list. Okay, and then C is the common section length of the common section of both linked list. Okay, now how much p1 will move. Okay, when I like switching the node, p1 will move the non-intersection point of first linked list. Okay, and the common portion as well, and the second second node, second linked list non-intersection point as well, right? And how much p2 will move. So p2 will move the non-intersection point of second linked list, which is B, and then non the common section of the both the linked list, and the non-intersection length of the first linked list, which is A, right? Now we can see that both P1 and P2 are traveling the same distance, right? Therefore, they will meet at intersection point after completing combined length of both the list. Okay, so when P1 and that's why basically P1 and P2, if there is an intersection point, they will intersect each other at a point. Okay, and if there is no intersection, in that case both P1 and P2 will reaches null, and we just need to check if P1 is null and P2 is also null, then you need to return the null, because in that case P1 and P2 there is no intersection and you need to return the null only. Okay, so I hope you are able to understand the intuition and why this switching is works. Okay, now I'm writing the pseudocode for the uh, like for this problem. Okay, so what I'll do, I will just take one pointer P1. Okay, that is pointing to the first node head A, let's say, and P2 is head of B. Okay, then what I'll do, I'll take while loop and check whether P1 not equal to P2. Okay, then what I'll do, I will move the P1 dot next, and P2 dot next. After that, what I'll do, I will check if P1 equal P1 equal to null. That's mean, and P2 is equal to null. That's mean we are both the pointer reaches to null. That's mean there is no intersection, right? So in that case, you need to return null. Okay. Otherwise, what I'll check if P1 is null. Okay, and in that case the P2 is not equal to null, because we are writing the condition before that. Okay, so if P1 is null, then what I'll do, I'll just switch the P1 pointing to head of the second linked list, right? So P1 now pointing to head of P, and if P2 goes null, okay, then P2 will pointing to head of the first linked list, which is basically head A, right? And after that, at certain point P1 will matches the P2. In that case, and just to simply return the P1, right? And here the time complexity is order of m plus n. Okay, so I hope you are able to understand the solution. I will also provide the code in the description section, so please check it out. Thank you.